Hello everyone, welcome to Adson Engineering Academy. It's me, your tutor Adson, and today we're going to do one important aspect in civil engineering. That is to say, bar bending schedule. You need to know before you go to buy this, what we call the bars that we use in construction. You need to know what amount do you need to buy and to what extent are you going to apply in the construction. So how to cut them, we're going to look into that. So let's dive in and see how to do it. Now, in the previous video, I made some explanation on how to do the mixed design or to cast a beam, and the dimension of that beam, the length of it was given to be 1200 millimeter. And that is the very same beam that we are going to see how can we make a bar bending schedule of it, okay? But you can take a leave, you can take an explanation from this and apply it in any field, in any part that you're doing, you want to do your bar bending schedule. I will make the explanation clearly step by step so that you can get it. Now, if this is the beam that I have, I need to understand a few things before I calculate what we call the cutting length of this beam, okay? The first thing that you need to know is the cover. What could be the clear cover in this case? Now, if you look at this from this extreme end to reach this part, okay, we're considering that this cover is 15 millimeter. Now, someone will ask, why are we chosen 15? According to IS code, the minimum is supposed to be actually 25, but this is a smaller beam with a smaller dimension. That's why in our calculation we are taking 15, okay? Now, if the clear cover, the cover or what I'm leaving from this side is 15, the downer part I'm also leaving 15, okay? This is particularly for this, but according to IS code, you're supposed to leave at least a minimum of 25. Well, how then can I calculate what is called the cutting length? Because all I need from this is what we call the cutting length, okay? So cutting length L. What could be the formula of calculating this? In this situation, you need to know that if from this up to this part is straight, okay? So let me call that one L dash. That part is straight. And what about this other remaining part? From this part up to this part only is given by the formula K plus 1 into D. Now, there are two things here. There is K and there is D. First of all, D is the diameter of what? Of this main bar that you're using. And then K is a constant. And that they're separate. If it is a mild steel, K is 2. But if it is tall steel, K is what? Is 4. And in this case, what we're using is the second one. So our K is going to be what? 4. Correct? Then what could be this span from here up to here? This particular part is what? This part is taken to be 4D. So that means if K is 4, 4 plus 1 is 5. 5D plus 4D. The whole of this bend part here is going to be 9D. Okay? 9D on both sides. So if on this side is 9D, on this side also 9D. Okay? So now if I want to calculate the length of this bar that I need to cut. First of all, you know that the length from ear to ear is what? Is L dash. You don't know because you have to calculate it. Okay? And then you know that from what? From ear to here is 9D. Then from this part to this part is also what? 9D. What could be the cutting length? Let me clearly write it here. Cutting length L is going to be first for the total span, which is 1200. That is what I know. Okay? Now, let us subtract away the clear cover. So, this part, where I have this to this, is what I'm calling the clear cover. On this side also the same, to this, is what I'm calling the clear cover. And it is 15. Meaning that I will have 2 of them times 15. Okay? Yes. And then, now I will have to add this portion of from here to here, which is 9D on both sides as I've clearly explained. So 9D from this side, that means it's supposed to be 2 times what? 9D. Okay? Well, so this is L equals to 1200 minus 30. And then plus 2 times 9 is 18. So this is 18D. So that means it's going to be 18 times the diameter of the main bar. And the diameter of the main bar in this case, we're using what? 8 mm. Take this diameter of this main bar we're using is 8 mm. So if you do this correctly, what you're supposed to obtain is 1314 in terms of millimeter. And this is in terms of millimeter. You can also divide by 1000 to get it in terms of what? Meter. Okay. So this is only one bar. And for us to cast a beam like this, we need 2 main bars from the bottom, then 2 bars from up, which is the angle bars. And in our design, we're considering both of them from bottom and top to be 8 mm dia bar. Now, that means I need 4 of them, but only one bar is taking length of 1.3. What about 4 bars? Okay, it's going to be 4 times 1.314, and this answer is going to give you 5.256 in terms of meter. So this will be the total length of the bar that I will require. Okay, so if you have your bar, you take it and you will have to consider this total length for all the 4 bars. Now, allow me also show you how to get the cutting length of the stirrups. So this is our stirrup, and the following things are what we require. Our clear cover still remains 15 millimeter. Okay, then what else do we know? A bend. If a bend is 45 degree, you take it as 1D. The length of that bend is 1D. If it is 90 degree bend, it is 2D. And if it is 135 degree bend, it is 3D. This will help us, and we really require it there. Now, what I want to calculate is also the cutting length of what? Of the stirrup. Now, cutting length, let me call it L again. First of all, I have to consider the center to center for this what beam. The red thing is the main bar. Then this black one running all around is what I'm calling the stirrup. And we are taking the stirrup of 6 dia bar. Okay? So the formula for calculating cutting length is equals to 2 into center to center of this one, of this bar on the vertical plane, on the vertically like this. It is A. As you can see, I'm calling it A. From the center to the center of the what? Main bar. And then plus center to center horizontally, I'm calling it what? E. Okay? Well, now I have to add what we call the hook length. The hook length in this case is this one which is protruding inside, these two. Now, what happens is that you either consider, in some cases, other people take it 10D, okay? But this is a smaller beam and a smaller stirrup, so we're considering hook length to be 5D or 75, okay? Now, whichever is big, you consider. So this is 5 times the dia of the stirrup is 6. So this would be 30 or 75. So in this case, we take 75 because 75 is bigger. Okay. So that means my hook length will be 75. Now, here we subtract the bends. Okay. because otherwise it would be very long. So the bends, we have to subtract it away. Now, how many bends do we have? 90-degree bend, we have 1, 2, 3. So there are 3 90-degree bend, and 90-degree bend is equivalent to 2D in terms of its length. Okay? And what about this other bend remaining? This other bend is 135-degree bend. Okay? This one, where we have the hook. And there are 2 for this and for this. So that means 135-degree bend, there are 2, and each of them is 3D. 3 what? 3D. This is the formula that will help you to calculate what? The cutting length of the what? Of the stirrup. So this is 2 in 2. Now, the question is, what is my A? Okay? My A is from here to here, which is center. First of all, the total is 150. 1 what? 150. Minus. Now, I know that this part is a clear cover, which is 15. This part is also a clear cover, which is what? 15. So that means just to reach here, just to reach the bar from outer side is 15. But I'm taking from the center of that main bar, meaning that it will be half of this main bar. Diameter of the main bar is what? 8. So divide by 2, 4. So 4 plus 15, it will be what? 19. So from the center of this to this is what? 19. So on both sides, center is what? 19. Okay? Now, that means I will have to take away what? 2 times 19, which is 38. 38. That is only the part for A. Do the same for E. E is from here to here, which is first of all the total, which is 100, minus center to center. From here to this part is also 15. This side is also 15. So plus half of this, which is also what? 19 now in total. So that means here would also be what? Minus 38. Okay? Yeah. So, well, so you had your what? Your 75, then minus, this is 6D minus 60. So this is minus 12 what? 12D. Okay? 12D. So if you calculate carefully, you're going to find that this one is coming to, the whole of this bracket is coming to 3, 4, 8. Okay? Now plus 75, then minus 72, which is 12 times diameter of this bar, and this is stirrup, okay, is 6. That's why it is 72. So the total length is therefore going to be 351 millimeter. Okay? Well, now we know that this is unequivalent for one stirrup. One stirrup is 351 millimeter. But how many do I need for? According to my design, the beam require 10 stirrups. So 10 stirrups means I am going to have 10 times 351. And this is 3510 millimeter. The total length in terms of meter is going to be 3.51 meter. Okay? So this is how we get the cutting length of this particular what? Particular stirrups, and the one for the what? The main bar. Well, when you go to buy these particular bars that we have calculated their length, you won't get them in terms of this meter. So you need to calculate it in terms of their weight. Okay? And how do we get this? Let's start with the main bars. Okay? The main bars. I'm calling them MB. These main bars, if I want to get their weight, the formula is clearly D squared. D stands for the diameter. out of 162. And then I'll multiply with the length that I require. Okay? Yes. Now in this case, weight is going to be the main bar, the diameter is 8 square, divided by 162 times the length of the main bar I have already calculated. Okay? So what I got is 5.256. This is the length of the main bar. So if I'm going to buy it, if I need exactly only this, okay? How will I measure it? It is giving me 2.076, and this is kilogram. So if I want to buy it, they will tell me 1 kilogram is at this what amount. Then I will pay for it. Okay? Then what about for the stirrups? Let's have that for the stirrups here. Yeah? For the stirrups, the weight of the stirrup, the formula still remains the same. Diameter of the stirrup, d squared, out of 162, then times the length that I require. This weight, I found that we have d is 6, and this is going to be 6 squared divided by 162 times the length of the what? The stirrups that I've calculated, which is 3.51. If you calculate this, you are coming to 0.78 in terms of kilogram. So if you want to buy it, you must calculate it in terms of kilogram, not in terms of what? Meter. So I've done in both cases. In terms of meter, because we're going to cut in the what? To do the casting in the lab. Then in terms of kilogram, when you want to what? Buy. Thanks so much for watching that video till the end. I hope you have enjoyed it. If you like it, please do share with your friends, like the video, comment on it, and above all, subscribe to Hudson Engineering Academy so that you don't miss such kind of important content.